Hey guys, Dip here. Today I'm making a tutorial. Hey guys, Dip here. Today I'm making a tutorial on Prim's algorithm, what it is and how it works, how you can apply it to graphs such as this one. So Prim's algorithm works on weighted graphs with labels such as this one here. And what it does is it creates a minimum spanning tree. So what is a minimum spanning tree? It's basically just like a path that visits every single node within the graph, just like this, and it does it in a way that doesn't create a cycle. So this is fine. This is not a cycle. The moment you get a cycle is when you like create a pocket such as this one, where there's like there's space here and there's like a circle, it's like a loop, so it connects back up. So you want a spanning tree such as this one, go visits every node without creating a cycle. And a minimum spanning tree is basically a version of this, which when you add up all the weights on the edges and nodes, it creates the lowest possible number, so like lowest possible sum, I should say. So how Prim's algorithm works is like this. So you can choose any node at all. It doesn't matter which one. That's the beauty of it, because you can start on A, perhaps maybe B, maybe E, C. It doesn't really matter. Just choose any of them. So I guess I'll start for this tutorial with A. So let's say we start at A. How it works is you basically just scan every single edge that's going outward. So you can like see here, A is connected to F with a weight of 3, A is connected to E with a weight of 2, A to C with 7, and A to B with 6. And how it works is actually it's a greedy algorithm. So how it works is it chooses the lowest value out of all of these. So as you can see, the lowest value would probably be 2 here, 2 here. And how it works is it just creates a graph. So say we have, I'm just replicating it using the Prim's algorithm. So let's say we start at A, then it connects over to the cheapest node, the cheapest edge, actually follows the cheapest edge all the way down to E here. So it goes down to E. These are pretty big circles. I don't know if I can fit them all, but yeah, it goes down to E. Now what you do is, this is the first phase. So now that we've gone through to E from here, from A to E, as you can see here, we do it again. So we check all of these here. So connected from A and E. So these are like now just like a unit, as you can see here. And now we just check all their neighbors and do the same thing. So for A, it's connected to F with 3, A to B 6, A to C 7. And again with E, since they're both now part of this spanning tree, you have to check for neighbors of each one of these. So for E, it goes up to F, D, C, and so what you do is you just search for the lowest cost edge again. For this case, we would probably be not looking at this one. We're looking at probably E to F, which is 2, I believe. Yep, so you would go ahead and select that because this is the cheapest edge. You just follow it, trace it up to F. We can add that to our minimum spanning tree. There we are. And again, we do the same thing. We check for the neighbors for every single one. I'm going to spare you the trouble for this one, and we already know which one it is. It's actually F to D with a weight of 1 over here, as you can see. And that would go up to here, and you'd create one of these up to D. So that should be labeling these, actually. So we went from A to E with 2, E to F with 2, and F to D with 1. As you can see here, we've actually got these little like lines here. As you can see, we've just been ignoring these. You want to ignore these when they come up. If they create a cycle, it doesn't matter if it's the cheapest node. If they create some sort of cycle like this, you can't have it in the algorithm. So the algorithm ignores any of those cycles. So yeah, so D to E wouldn't work because it would form a cycle here. So you wouldn't want to do that. So again, following the same principles as before, you just look at the neighbors of E, A, F, D, and C if you can reach another node without creating some sort of cycle. So for this one, I think everything on this side of the graph is complete. I don't see any other nodes I can reach from there. So I'll go ahead and just look at E and A. Again, so A to B 6, A to C 7, E to C 5, which is the cheapest one currently. So you just go ahead and draw that up and then add that to our spanning tree. So E to C over here, E to C 5, and then again from here, you'd go A to B, which is 6, and C to B, which is actually 5, which is cheaper. And again, this does not create a cycle. It's still broken up into a neat little a tree here. So you can see there is no cycle. You can trace this whole thing around, and there are no cycles. And that would be your minimum spanning tree. So if you go ahead and draw the last one up here, do 5. You can add these all up to get your sum. So 4, 5, and then 15. So this would be 15. Your sum of this graph is 15. Again, so you can also do this with other starting nodes. It doesn't matter which one you start at. Eventually, you will end up getting to this same tree, so this minimum spanning tree, and that's how you apply it. If you like this video, go ahead and subscribe to the channel. Offer code EndMyLife if you want to get 100% off your subscription to SuperDerp channel. There's a 1 in 10 chance that you might get a virus, but if you don't, you are lucky. Thank you for subscribing. Again, offer code EndMyLife. That's right, it's EndMyLife. Go ahead and hit that subscribe button if you want to, I don't know, perhaps get cursed for the rest of your life. I come out with videos once every millennia, and with that being said, thank you for watching. I'll see you next time.